Hello, Assalamualaikum and good afternoon. I'm Dr. Syahiman. From the previous videos, we have covered two criteria of designing a grid connected PV system. In this video, we're going to cover another one criteria, which is to design a grid connected PV system based on yearly energy requirement, or also called as the annual energy yield. Okay, what is annual energy yield? Annual energy yield is the target of energy or kilowatt hours or megawatt hours that you must achieve in order to accomplish your PV system. So if you don't get that target, means that you are undersizing your design, means you have not successfully design your PV system properly and appropriately. Okay, that's why it's very critical to achieve the target of annual energy yield. Okay, the calculation also is quite complex compared to another previous two criteria. In designing the PV system based on energy requirement, you have to consider, we call that as subsystem losses. These subsystem losses mainly comes from the following factors. The first one is from inverter efficiency. So inverter efficiency is very easy for you to get that value when you are trying surveying or buying the inverter. You're going to have the data specification or the data sheet. So in that data sheet, usually sometimes they write maximum efficiency, euro efficiency. So that efficiency is the inverter efficiency. I may say that the typical value for the inverter efficiency may varies from 92% to 97%. Sometimes in average they call it 95%. So you know, right? The inverter is to invert the DC voltage coming from the PV module directly to the AC voltage, where it is going to be exported to the electricity provider. Okay, so that inverter efficiency is totally affect to the output of your system. Okay, the next factor is cable losses. Okay, cable losses is quite critical. It depends on two factors. One is the cable thickness, and another one is the cable length. If you're using suitable thickness of the cable, you can avoid the voltage drop or huge voltage drop. If by mistaken you under design your system and you use the thinner cable, so you're going to face a dangerous situation, which is the huge voltage drop. When the voltage drop is getting higher, it means that the flowing currents is not following the spec of the cable, so the cable will melt. Once the cable melts, you can imagine it can lead to the fire, okay, and also the explosive condition also. Okay, the second one is the cable length. The longer cable you get, the longer chance for you, the higher chance for you to get the huge voltage drop. So the target, of course, is to shorten the cable length from the PV module to the inverter or the kilowatt hour meter. But if by case you cannot avoid it, you still need to use that, for example, 10 meters long of the cable. So you're going to use the thicker cable so that you can totally reduce the voltage drop that comes directly from the cable. Okay. The third one is the average yearly irradiation for certain angle and orientation. Okay, what is the average yearly irradiation? We have covered in the previous chapters. The same meaning of the PSH, peaks and hours. It's the same meaning. For example, in one day, we assume in Malaysia case, when we are doing design of PV system, we consider we get the 4 hours of 1000 watt over square meter of continuous sunlight strength. Okay, one day you get 4 hours, means in 1 month, how much you get? 4 multiplied with 30, you get 120 hours. So that one for a month. We assume we have 12 months. So 12 multiplied with 120, we are going to get 1440 hours of PSH per annual, or we call annual peak sun hours. So it's the same meaning of average yearly irradiation. So the more you get sun hours, of course, the better output of the system you get. Okay. The fourth one is the manufacturing tolerance of module and mismatch. This value only can be obtained through the datasheet that provided by the PV manufacturers. When you're buying or you're surveying the PV modules that you're going to use for your system, usually they are going to write in the word of manufacturing tolerance, power tolerance, or sometimes they use only tolerance. And the value is in plus and minus how many percent. For example, plus minus 5%, plus minus 3%, or sometimes they show you in the minus 0 plus 5%. Okay, that are the value of tolerance that you can obtain directly from the datasheet of the modules. Okay, next, temperature facts. We have covered the PV module characteristic in the previous chapters. Like we have known already, from what we learned, uh, temperature is the enemy of the PV module based on silicon material. While the solar irradiant is the ally of the PV modules for the case of silicon-based, silicon-based materials. So the higher irradiant you get means that more energy you're going to generate. More energy going to be generated means more current will be produced through your PV module. So that's the solar irradiance. Second one is temperature. When the temperature is getting higher, the performance of your module will degrade. Okay, why? Because we cover also. You can reverse back to the slides. I think chapter 3. The highest temperature, the voltage will significantly decrease. When the voltage is significantly decreased, the power also will follow the same trend. The last one is the effect of dirt on the modules. In average, we may consider 1 to 2%. It's normal cases in Malaysia. But when the place that are dirty and soiling, like there's a place in Arab place, for example, in South Africa, which is the desert land, because there's too sandy, sometimes they have the sandstorm, so that one can consider until 10% of the dirt. Okay, in Malaysia case, because we are receiving sometimes seasonal, sometimes frequent rain, so the dirt on the module surface of the modules is considered clean when the rains come. That's why 1 to 2% consideration. Okay, maximum sometimes 5%. Okay, right. Yes, the subsystem losses when you design of PV grid to PV system based on the energy requirement, that must be considered. Okay.